I put in 2.675 right there. And there we go. We got our tail percentages. So I got 0.0039 in this tail and 0.0039 in that tail. Now remember, if this was a right-tailed test, then the p-value would be 0.0039. But this was a two-tailed test. Our alternative hypothesis was not equal. So if we add the two tails together, we get our 0.0078. And that's where StatCato got, right here, the p-value 0.0078. It actually added the two tails together. Okay, so that's a good picture of critical values in test statistics and p-value. Now, what if I wanted to do this problem with randomized simulation? What if I didn't want to find a test statistic or critical value? I wanted to judge it based on randomized simulation or randomization. Well, we can do that. So if you go to StatKey, just go to randomization hypothesis test, and we're going to click on test for single mean. There we go. All right. So now I need to change the null hypothesis. The null hypothesis, remember, was $11. So I'm going to put in 11. Now I do need my data. So here's the data here. It's from the fall 2015 survey. Again, I copied it. Under Edit Data, I'm going to delete out the data that's in there and put in that data. Now again, I'm not sure if we'll see if StatCato likes this title. Sometimes it doesn't like. It didn't seem to like the title last time, so I think I'm going to delete out the title. There we go. And that way I'm going to uncheck the box that says header row. So it doesn't have a header row, doesn't have a title. It also doesn't have an identifier. Remember, an identifier is a word next to every number, and this doesn't have that. All right, so there's our sample data. Now what we want, so you can see the sample mean, 11.898. Now what I want to do here is to go ahead and take random samples from under the premise that the null hypothesis is true. So if the population mean really is $11, what kinds of random samples should we see? So I'm going to generate a few thousand random samples here. These are simulated samples based on the premise that $11 really is the population mean. This is what sampling variability looks like if the null hypothesis was true. Again, we are looking for a two-tailed test, so I'll click two-tail. Now, normally if this was a z-score, a t-score curve, a t-distribution curve, these numbers down here would be the critical values, right? But they're not. These are actually dollars now. These are numbers that are meant for you to compare your original sample mean to these numbers. So they said anything bigger than $11.69 would have been considered significant. Anything lower than about $10.37 would have been significant. So in our case, our original sample mean was 11.898, which is over here, right? It's in this area. So it's definitely significant. So it's kind of, randomized simulation is very similar to using the traditional approach, but you're again looking at the sample data directly instead of through a test statistic and a critical value. And you're not using the theoretical curve anymore. Okay, so if we go ahead and do that, now remember, this is not the p-value, right? I need the p-value. This is the significance level. 0.05 broken up into two tails is 0.025. That's not the p-value. The p-value would be the probability of getting this original sample mean. Okay, so what I'm going to do is in this right box, I'm going to type in 11.898. Now, if this sample mean was closer to this left box, I might type it in the left box, but this one looks like it's definitely above 11, so I'm going to put it in this right box. So I'm going to type in 11.898. And there we go. So we have our tail percentages. Notice there's two tail percentages, 0.0052 and 0.0052. Again, there is sampling variability involved, so my numbers that I'm showing you right here in this simulation won't be exactly the same as what you get when you do a simulation. My random samples are not the same as your random samples, right? That's the principle of sampling variability. So, but we do need to add these two percentages together to get the estimated p-value. So if I add these two together, looks like we get about 0.0104. Which is still quite a bit lower than our 5% significance level. So we're still going to reject the null hypothesis, and it's unlikely to be sampling variability. Okay, so our sample data does significantly disagree with this $11, and our p-value was low, so it's unlikely to be sampling variability. And so we're kind of rejecting the claim, right? This is all kind of stuff we did in the previous video, but this is just showing you how you can get these numbers with the computer software. Okay, so I hope this was helpful for you. So we did the t-test for traditionally with StatCato. We also looked up the numbers on the t-distribution calculator, theoretical distribution calculator in StatKey, and then we also did a randomized simulation version of the hypothesis test. So I'm hoping this was helpful for you. So this is Matt Touchot in Intro Stats, and this was one population hypothesis tests with software.